All right, hello math students. Today we're doing 6.6. We are diving deeper into our unit circle discussion. And you'll see why as we go into it. Really, we're making sure that we know that pi is 180 degrees, or pi radians, right? And that's what we're double checking, making sure that we know how to go from radians to degrees. And that's what they're doing with this lesson. I already kind of pre-taught this, but it's a good lesson here. So we have 3 students, Alice, Javier, and Veronica. They're preparing for discovery at archaeological site. People who used to inhabit this site built their city around a central tower. So the first job of the planning team is to mark the sites using stakes so they can keep track of where they discovered items. So Alice suggests that the team place stakes in a circle around the tower, with the distance between the markers on each circle being equal to the radius. So we're saying the length from stake to stake is the radius. Javier likes the idea, but he says the number of markers would depend on how far away the circle is from the center of the tower. Do we agree or disagree? Well, we should know that the circumference, if we want to know the whole circle, is 2 pi r. So if we are doing the length, we call it the arc length. So the arc length is like the length but on a curved surface, okay? The arc length has to equal r. So we're going to do circumference divided by arc length. So 2 pi r divided by r will be 2 pi. So no matter what, we have the same constant. So I disagree with Javier here because we will have the same number of stakes because we have this constant when we do circumference divided by arc length. So now what we have is we want to show where the stakes would be using this method. If the small circle, we have a radius of 12 meters, and the big circle has a radius of 18 meters. So really, what I'm going to do is I'm going to do it like here to keep these lines the same. So the big is 18. So if my first stake is here, then I have to go 12 meters because the radius is 12 meters. So I'm trying to think. We go 12 meters, 12. Okay, so let's go 2 pi 12. And we go 2 pi 18. Okay, and we want them 12 meters apart. Means we should have around 2 pi stakes. Well, 2 pi is about 6.28. So we'll have roughly 7 stakes, right? There's 12. That's 12 meters. That length is 12 meters. This length is 12 meters. 1, 2, 3, 4, 5. Sorry, I'm slightly off on my meters. I'm estimating, I'm trying to eyeball this one because this one is the fast one. So 12, 12, 12, 12. Then we have 12. And this length in here is 12. And then we have another point here for 12. And then another one here at 12. So 1, 2, 3, 4, 5, 6, a little bit more, makes it 7. Boom, 18. 18, 18, 18, 18, and 18. So that's our eyeball estimate. Okay. And that's what our circle looks like with stakes, where the radius and the arc length is the same. So we have arc length equals radius. Remember, the arc length is a measurement of the curve between 2 points. Instead of a line between 2 points, it's a curve. That's why I call it the arc length. All right. So with that, let's go on to 3. So now, after looking at the model, Veronica says they need to have more stakes if they intend to be specific with locations of the artifacts. Since most archaeological sites use a grid to mark off sections, Veronica evenly spaces 12 stakes around each circle. Using the coordinate grid, label the location of these stakes. Central tower is located at the origin. The first of each of the 12 is placed at 12, 0, and 18, 0 respectively. Alice wants to make sure they record the distance around the circle each new stake. From these initial stakes, your job is to determine the x and y coordinate for each remaining stake in the circle, as well as the arc length from the points, depending on where the stake is located. So what we should know is I have 12. So to go a whole circle is 360 degrees. We want to do 12 stakes, so that means 12 divided by 360 is 30. So each stake is going to be 30 degrees apart. So what I have here, so I'm going to make it 30 degrees. So really, we're making these triangles. So the first triangle I have a radius of 12, 30, x and y coordinate. So we should know that the sine of 30 is y over 12, so y is going to equal 12 sine of 30. Vice versa, cosine of 30 is x over 12, so x is going to be 12 cosine of 30. So if I do 12 cosine of 30 and 12 sine of 30, I get 6 and 10.39. So 10.39 to 6. So there's one coordinate. Okay. This is the small. Okay. Radius is 12. So that's the coordinate 10.39, 6. So that's that angle. We're going to do the same for the 18, but now we're going to do 60 degrees. So if I do 60 degrees, it's the same math. So I have that x is 12 cosine of 60. Y is 12 sine of 60. This is going to repeat, right? So we're going to do this for 30 degrees, 60 degrees, 90 degrees, 120, 150, 180, 210, 240, 270, 300, 330, and that's it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the first one is 12 at 0 degrees. So those are the 12 stakes for the degree measurements. So all I do is make a 30-degree angle there, then I'll make a 60-degree angle. Well, cosine of 60 is 1/2. Half of 12 is 6. So 1, 2, 3, 4, 5, 6, up to, so that coordinate is going to be 6, 10.39. Interesting that these are just inverses of each other, but that should look right for our sine and cosine. We're up here at 0, 12. Then I have to go 120. 120, this should match here. So it will be negative 6, 10.39. This line matches here because we're going to go evenly across, and that'll be negative 10.39, 6. So all we're doing is switching between 10.39 and 6 on the points, or 0, 12, negative 12, 0, and so forth, because that's the pattern we see. So if I wanted to show you the math, right, if I did 12 sine of 120, 12 cosine of 120, hey look, 10.39, negative 6. 10.39, negative 6. 12 sine of 150, 12 cosine of 150, hey, guess what? 6, negative 10.39. Remember, sine is y. And x is cosine. But this time our radius is in 1. We're using the radius of 12. Right? Negative 12, 1, 0. So if I do 12 sine, or cosine, because I'll do x first, cosine of 210, 12 sine of 210, negative 10.3, negative 6. So hopefully by now you're seeing a pattern. So this one's going to have to be negative 6, negative 10.39, 0, negative 12, positive x, so positive 6, negative 10.39, positive x, negative y, negative 10.39, no, 10.39 comma negative 6. Okay. So that's how it looks for the 12, for the big circle. It's the same, except x is going to be 18 cosine of 30. Y is going to be 18 sine of 30. 18 cosine of 30, 18 sine of 30. And so I get 9, 15.59. 9. (18 cosine of 60, 18 sine of 60, 9 comma 15.59. Then I have 0, 18. That's 90. Right, if I do that, 18 cosine 90, 18 sine 90, 0, 18, right? 18 cosine 120. Oh, yeah, 18 cosine 120, 18 sine 120. Negative 9, 15. Positive y, negative x. So if you saw that, it's going to be the same. This is going to be negative 15. Positive 9. Then I'll have negative 18, 0. Then I go down here, and I should have, again, negative 15, 5, 9, and negative 9. Now we're negatives both. So negative 9, negative 15.59. This point is going to be 0, negative 18. Going back, I get 9, 15.59, negative 15.59, and then 15.59, negative 9. And there's your coordinates around that circle. Okay, now for 4, Javier suggests we record the location of the distance around the circle. Veronica suggests by making it interesting by writing the ratio of the arc length and the radius. So for stake 2, 10.396. This was 6, 10.39. This was 0, 12. Negative 6, 10.39. Negative 10.39, comma 6. Then we're at negative 12, 0. Negative 10.39, negative 6. Negative 6, negative 10.39. 0, negative 12. 6, negative 10.39. 10.39, comma negative 6. Okay. Going the other, in the 18, the bigger one. The bigger one we started with 15.59, comma 9. Then we go 9, comma 15.59. Then we have the radius of 18, so 0, 18. Coming back, if we go back, we have the smaller y first, but it's negative. Then negative 15.59, comma 9. Then we're at negative 18, 0. And then I'm at, sorry, if I go back around, I start at negative 15. But this time both are negative. Negative 9, negative 15.59. I have 0, negative 18. Then come back to the positive, so 9, negative 15.59, 15.59, comma negative 9. Okay. For the distance along the circular path, okay, remember radius 12. This will be the distance is 12 times 2 times pi divided by 12, so that's just 2 pi. So 2 pi, then 2 pi plus 2 pi is 4 pi, plus 2 pi is 6 pi, then 10 pi, 12 pi, 14, 16, 18, 20, 22, 2, 4, 6, I forgot 8. Yikes. Forgot a number, I was like, I'm doing something wrong. 8, 10, 12, 14, 16, 18, 20, 22. Now, the second one should be 2 times 18 pi divided by 12. So 12 divided by 2 is 6, so that's 3. So 3 pi, 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, then 21, 24, 27, 30, and 33. All right. Well, the ratio of the arc length, so this is by degrees. Remember, we counted by 30. We were in 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. We just have to do a conversion rate of pi equaling 180 degrees. So at 180 degrees, we're at negative 12, 0, negative 18, 0, we're back at pi radians. So 30 times pi over 180, that'll be pi over 6. 60 times pi over 180, pi over 3. 90 times pi over 180, that's pi over 2. 120 times pi over 180 divided by 6 makes that 2 and 3, so that's 2 pi over 3. Then I have, that's 150. 5 over 6. Now 210, 7 pi over 6. 240. Divided by 6, 4 pi over 3. 270. Divided by 9. 3 pi over 2. 300. Divided by 6 is 5 over 3. And then finally 330. Divided by 3, 11 over 6. So all we're doing is adding pi over 6 each time. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. What interesting patterns might Alice, Javier, Veronica notice in their work and their table? Summarize any interesting finds we notice. So we should notice that the ratio of arc length to radius is the same for each stake because it's equally around. The arc length, x and y coordinates, of points on 18-meter circle are all 1.5 times larger than xy coordinates on 12-meter circle. Hence, 12 meters times 1.5 is 18 meters. And then relationship between radius and arc length is proportional. Means you create a fraction out of it. All right, and that's my lesson notes. Thank you for listening. I know this was a long one, but thank you for holding there and listening to this one.